moving toward the next named reaction, which is Des-Martin oxidation. Firstly, have a look at its history. Basically, this reaction was developed by two chemists, Daniel Benjamin Des and James Cullen Martin, and that's why it is named as Des-Martin oxidation. Both chemists developed the periodinane reagent in 1983. In 1983. Periodinane reagent is basically a primary reagent which was used in Des-Martin oxidation to oxidize primary alcohols to aldehydes and secondary alcohols to ketones. Let's moving towards the definition of the Des-Martin oxidation. Basically, it is a mild synthetic method which is used to convert primary and secondary alcohols to aldehydes and ketones respectively. The reagent we will use is Des-Martin periodinane and the structure is given here. And the Des-Martin periodinane is prepared by two-step synthesis from 2-iodobenzoic acid. The reactants we will use here are alcohols and the products we will form that will be produced from these reactions are aldehydes and ketones. Moving toward the introduction of the Des-Martin oxidation. As we know that alcohols can be oxidized to aldehydes, ketones, carboxylic acid, and they depend on the structure and the type of oxidizing agent. So, we can classify oxidizing agent as strong and mild oxidizing agent. Firstly, we will see what are mild oxidizing reagent. Basically, mild oxidizing reagents stop the oxidation of the alcohol once the carbonyl group is formed. And if the alcohol is a primary, then the product is an aldehyde, while the oxidation of secondary alcohol results into a ketone. The second one is strong oxidizing agent. Basically, the strong oxidizing agent oxidizes primary alcohols to carboxylic acid and secondary alcohols to ketones. Here I have quoted some examples. We can see that there is oxidation of alcohol using strong and mild oxidizing agent. Firstly, in the first reaction, we can see that primary alcohols in the presence of strong oxidizing agent, which is H2SO4 or maybe Na2Cr2O7, it will be converted into a carboxylic acid. In the second reaction, we can see that there is a secondary alcohols which in the presence of a strong oxidizing agent like KMNO4, it will be converted into a ketone. So these are the examples of strong oxidizing agents. There are some oxidizing agents who can selectively oxidize primary alcohols into aldehydes, and these are as follows. We can see that there is a primary alcohol which in the presence of PCC or PDC, which are also are oxidizing agent, and it will convert them into aldehydes and other. Basically, tertiary alcohols cannot be oxidized, so except for burning them to carbon dioxide. So we can see that there will be no reaction with tertiary alcohols. Next is the mechanism of the reaction. Basically, this reaction starts by substitution on the iodine, where the alcohol replaces one of the acetate ion followed by a deprotonation which forms an aryl iodoester per iodinane intermediate. As we can see in the reaction, there is a secondary alcohols in the presence of Des-Martin reagent. It will be converted into a aryl iodoester per iodinane intermediate. And after that, this per iodinane intermediate is then transformed to the corresponding carbonyl compound by a possible intermolecular removal of the alpha hydrogen to form a carbon double bonded to oxygen, or we can say that then this per iodinane intermediate is then transformed to the corresponding carbonyl compound by a possible intermolecular removal of the alpha hydrogen to form a carbon oxygen sigma bond. And the byproducts are 2ACOH, which is an oxidizing agent and a Des-Martin agent. Moving towards the application of the Des-Martin synthesis. Basically, it is a commercially available chemical which is frequently utilized as a mild oxidative agent for the selective oxidation of primary and secondary alcohols to their corresponding aldehydes and ketones. DMP shows several merits over other common oxidative agents such as chromium and DMSO based oxidants. Thus, it is habitually employed in the total synthesis of natural products. So, we try to understand the application of DMP as an effective oxidant in an appropriate steps in the multi-step total synthesis of natural products.